We are talking about the Sensei project, and the topic of the Sensei project is really how can I get the real world, all the information which we can gather now with modern sensor technologies and other areas which you can look at, and bring that into a digital world so that it can be used in a lot of different type of services. I'm coming from NSC. Let me give you a few words on the background which we are working on. This is the NSC Laboratories Europe. We are located in Heidelberg, Germany. We have been there for 12 years now, and we worked on all areas from somewhere above hardware, from 802.11 to service platforms, from IETF or 3GPP and NGN type of networks in a lot of areas like the future internet or intelligent transport systems. There's a few examples down there. We have, for example, an open flow router product, which is a direct future internet related aspect. We are collaborating, NSC is collaborating there with the people in Stanford and in the Genie projects on this open flow architecture. We have some cloud aspects here and, for example, also a strong team of identity management. Now, what I like to talk about in the Sensei, very brief introduction, you know, the standard slides of an EU project, who is there and what are we doing. But then I like to go to the key achievements and show you what we are doing here. We are big at IP with a lot of partners here, but a lot of partners who really bring excellent experiences into the project. For example, from Finland, we have Sensinode, who are really doing wireless sensor nodes and bringing new technologies into the sensor node, up to 6 low-pan implementations, which they actually helped in standardizing and bringing to the market. We have Telenor inside of that, who have really a subsidiary on smart objects communicating, and they have use cases. I remember that we all laughed some 8 years ago when Telenor predicted that they would have more sheep as GSM subscribers. Now they have companies which are really monitoring the sheep in the countries, which are monitoring the fish farms out on the ocean, where they try to do that without human intervention, so that they really need to go there. They want to open the food bowl so that food gets into the water and measure what the water quality and other things. They are all remotely, all without going by ship or helicopter out there. This example already gave some of the motivation, and I'd like to repeat what we're trying to do. We see there's a growing importance of integrating the physical with the digital world on the context awareness, which was a topic which we already discussed about that, so that we have more of this smart, intelligent, somehow invisible and autonomous application services that are making use of this information. What we have analyzed at the beginning of the project, that there's a lack of an open framework for these wireless sensors and actuator networks. And that a lot of what has been done at the moment is very vertical and very closely integrated aspect. And there are great examples out there, but there's not a really good open framework, and that is where one of the major contributions from Sensei is to be expected. We have analyzed many application space, looked into different application scenarios, and out of that then tried to come up with the core requirement and for the Sensei system, which we formulated in challenges for the real-world internet, which is our part of the future internet, which we like to drive forward. And what you see here is basically numbers of devices and users. They are going to be a magnitude larger, a shift of from the user as the communication endpoints to really humans and machines talking in a single system, even machines directly and automatically talking to each other. And there's the challenge of all the scalability in that area. Heterogeneity is going to explode. Many devices is going to provide you with sensor information, with their status information, with the ability to talk to this device and say, you do something for me. That's a lot of heterogeneity happening there. So we need to deal with this diversity, and we need to make sure that there's still an ease of interoperability and an ease of use in it. So an unified and controlled access to this information is a needed requirement here. We see the growing importance of the metadata or the higher level semantic information. We come to that a bit later on, but think about it. There's thousands of sensors out there, all of them doing some form of measurement, providing you with data, many of them probably giving you temperature. But you know, my laptop has around 8 temperature sensors built into that. This projector over there has temperature sensors to monitor whether it's overheated. There might be the air condition giving you a temperature. None of that gives you the actual outdoor temperature, but they're all temperature sensors. So we need to really understand what is measured and then use that later on in the application in the right way. And that, what we're needing here is the metadata and an efficient association and finding of the real right information in this big, huge information space. Out of the sensor information, context information is generated because that has all the semantics attached to it. And now, how are we managing these in our system? And this is the high-level view. There's a user, which you see here. He likes to find the resources which with him is interacting. And we have then a set of support systems which help us with specific areas of this solving the problem. The first thing is the big L-shaped thing around it. That is the resource directory. The resource directory is where you publish information to, where you look it up to find the right resource. And this is where we probably can talk to other projects on new naming systems, new rendezvous concepts here. We have specific requirements in these areas. Just to give you an example, we can simply provide the standard internet type of tags for our resources. So we can use a tag-based access. But we can also use a location-based access where we can say, look, in this area of the world, we are looking for information from CO2 sensors. So we can give geographic locations, and then the system should find us the sensors inside of that scope. That is our scope. Or we could say, within the network of this university, we like to find the attached sensors about, I don't know, where people are moving or fire or something like that. So that is what is happening. All of these different, sorry, I wanted to explain the component. I moved too fast to this thing and the computer's not moving back. So user trying to find resources, looking up in the resource directory. And in addition to that, in order to help him, we have what we call higher level components which help you to deal with the complexity of the sensor network with this 10,000 of nodes in some of the areas. Example, there's the semantic query resolver. I will explain that later, but in principle we can make a semantic query saying this is the type of information we need, and the resolver makes a plan how to get that information out of many, many sensors, put them to some aggregator components, and establish a processing flow network where the real high-level information is computed. The semantic query resolver generates the plan, the execution manager executes the plan, and in the execution process where he has told 10,000 sensors to send the information to London for processing there, he's monitoring this network. If new sensors come along, if some sensors are gone, he's changing the network and constantly adapting it.